well, nobody knows how they come out with this crazy formula.
There's actually a very interesting article that with the golden ratio, Beyonce is the second most pretty woman in the world.
Say it again, golden?
Using the golden ratio, I actually circulated the article with a couple of the colleagues, but using the golden ratio, Beyonce is the second most beautiful woman.
Oh, Beyonce, yeah, okay. We have to ask we have to ask we have to ask Jay-Z about that.
So that was pretty interesting.
I'm sure he's the lucky man then.
This semester, Rashidul Bari is teaching C++ at City University of New York. Watch his lectures to achieve
So
your
in the Fibonacci sequence, 1, 1 plus 1 is
2, 3,
1 plus 2 is
3, 5, 8, 13,
13 and 21 and so on. So we see this is what? This is recursive. This is a recursive sequence because the next one is depending on previous two. The next one, successive one, is the sum of previous two. So what can we write? Fn is equal to Fn plus 1 is equal to Fk plus 1 is equal to Fk plus Fk minus 1. Right? Because Fk plus 1 is equal to, oh, okay, so we have a formula. Okay, so forgot. We have a formula. Okay, so just like the other one, we have a formula. One, I probably wrote it, I'm not sure.
On the page, right?
Is square root of 5 plus 1 minus the square root of 5n over 2n is square root of 5.
Yeah.
Okay, hopefully I wrote it correctly, right?
That's good.
Okay. Now we are claiming that this, this gives you Fibonacci sequence. Just like the other one, other two. We good? But how do you know? Fibonacci told us, so we accept it? No, so we're gonna have to show the proof. And we'll do the proof. Okay, so for the proof, forgot that. Oh, sure, I'm gonna write it before I follow the induction process. Okay, now, what was the induction process? I forgot. The step 1 is check for
1.
Check for 1. Sorry, check for 1. Check for 1. All right, 1 is this guy, right? So 1 is equal to 1 plus root 5, 1 plus 1 minus root 5, 1 over 2, 1 root 5. So it's equal to what? 1 plus root 5 plus 1 minus root 5 over what? 2 root 5. 1 1 cancel, 5 5 cancel, so 0 over 2 root 5. Huh? No. No, 1 plus root 5 plus 1 minus root 5. This guy cancel, right? And 2 root 5, right? So 1 is 1 is 2 over root 5.
Should be 1 over 5. But you can't have the radical, so you gotta take the radical.
Say it again.
You can cancel the root 5 at the bottom with the 2 root 5s at the top.
No, you can't, because there's addition on the top.
Because the root 5s are the same.
There's addition on the top.
No, did I write it correct? Okay, 1 root 5, 1 minus root 5,
They add it together, you can't.
1 plus 1
It's not
minus root 5.
Yeah.
This should give us, okay, is it minus or plus, guys? Can you double check?
It's minus.
It's minus?
Minus.
There you go, okay. All right, okay, it cannot be wrong. I mean, I'm sure we are not the first one proving it. Okay. 200%. Okay. 1. Okay, over 2. Okay. All right. 1 plus root 5 minus 1 plus root 5 over 2 root 5. 1 cancel. 2 root 5, 2 root 5. Oh, there you go. 1 is equal to 1. So it works for 1. Now what is our next thing to do? Check for 2. If 1 is so hard, 2 probably be harder. Check for 2. Okay. So we know what to do. 1 plus root 5 square minus 1 minus root 5 square over 2 root 5. Oh, that's 2 in 2 times 1 times the square root of 5 plus the square root of 5 squared minus 1 squared minus 2 into 1 into square root of 5 plus the square root of 5 squared over 4 root 5. Okay, hopefully you catch the mistake if you have made one. So 1 plus 2 root 5 plus 5 minus 1 minus 2 root 5 plus 5.
I'm sorry, Professor, but the line before that, the writing is very small. I can't even tell if that's 1 or if that's 2. For the 1
I just
squared plus
1 square.
the best thing is don't take note, just take picture. Because it's gonna be so long that if I don't write, I'm not writing it like carelessly. I'm writing it intentionally small.
Or can you send it in an email?
Yes. I'm videotaping it. I'm gonna send you the video. So 1 plus 2 root 5 plus, but please take picture. You have the phone, right? Please take picture. Picture is better than the handwriting. So you can see me making mistake if I do make mistake. Minus 1 minus 2 square root of 5 minus 5. 4 root 5.
Combine like terms.
So
5.
1.
1, 5.
Oh, okay. Minus plus. Minus 1 plus 2. Okay. All right. I think that's it.
1.
This cancel.
And the 5's cancel.
5 cancel. Oh, okay. 4 root 5 or 4 root 5. All right. So the second Fibonacci number is 1. So this proves that 1 is equal to 1. The second Fibonacci number is 1. So it proved that 1 is equal to 1. Okay. What is the next step? Next step is
Okay.
yeah. So I'm gonna erase it.
No, let's do what you said.
Not 1 plus 1 plus 2. The second one is 1. So this is 1. So 1 is equal to 1. Okay.
Where are the plus 5s and minus 5s come from?
Oh, that's like this one. So this was by who? Gauss. This was by who?
Goose.
Fibonacci.
Oh.
Okay.
But like, you see on the I think it's the third line.
Oh, here?
Yeah, like where did the plus 5s get both from?
Plus 5.
Yeah, like what's it that you're squaring?
So a plus b square is a square plus 2ab plus b square. This is a plus b square, and this is a minus a minus right? That's the binomial. Okay, so we prove it for 1, and we prove it for 2. So the Fibonacci number 1 Fibonacci number is 1, number 2 Fibonacci number is 1. So we got 1 is equal to 1, we got 1 is equal to 1. So it works for 1 and it works for 2. Now we're gonna claim what? It works for k, hopefully. Can we erase it now? It works for k. Step what?
3.
Step 3 works for k. Since we have the background, we kind of try to understand it. It works for k. That means we're gonna write f of k is equal to 1 plus 5 k minus 1 minus 5 k over 2k is square root of 5. You see, we are doing the same thing, but this one is going to be a little bit complicated because it's recursive function. And this is most elegant recursive function. So step 4, it should work for k plus 1. So f of k plus 1 is equal to what? F of k plus 1 can be written as f of k plus f of k minus 1. Do I need to show that these two are equivalent, or you agree? F of k plus 1 is equal to f of k plus f of k minus 1. I'm going to give you a little proof over here. F of k plus 1 is equal to f of k plus f of k minus 1. Let's say k is what? K is any number.
2.
K, not 2. 2 is just 1. 5. 5 is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 is not. 5 is 5. Okay, give me 6. 6 is 8. 6 is 8, right? Okay, now our goal is to get 8 on this side and 8 on this side. So, or the same thing on both sides. So 6 plus 1, 6, 6 minus 1. So 7. Okay, f of 7 is what? 1, 2, 3, 4, 5, 6, 7. F of 7 is 13. F of 6 is? And f of 5 is? Okay, they're the same. That's proof, the little thing.
Wait.
Sorry. Okay, so then they are the same thing. So I'm not gonna write f of k plus 1. I'm gonna just write that. Or maybe I'll have f of k plus 1 here. Is equal to, what are we gonna have? This one. 1 plus the square root of 5k plus minus 1 minus the square root of 5k plus and divide by 2k plus 1 root 5. Okay. Alright, now we're going to prove the left hand side. The right hand side is good. Good. So our goal is to make this guy look like that. That's our end goal. Okay. And hopefully we'll get there. Okay, so we have this. F of k plus f of k minus 1. We're going to turn this one look like that. Okay. So what is f of k? 1 plus root 5 k minus 1 minus root 5 k over 2k root 5. What is f of k minus 1? There is a plus in the middle. Okay, so f of 1 plus root 5, we're going to write k minus 1 minus k minus 1 2k minus 1 root 5. Okay, we are not doing anything, we have not done anything important so far. Everything we so far did is like we did before, right? Okay. Now we have to do common denominator. This time doing common denominator is like not an easy job because the last time we just multiplied top and bottom and then we got it. In fact, this time we're going to multiply top and bottom and got it. Remember last time we multiplied top and bottom to make a common denominator? Our common denominator must be what? 2k plus 1 root 5. But this is not that, and this is not that. So how can we do that? What about we multiply this one by something?
By the other denominator.
By 2. Okay, if we do by 2, look what happened. 2 can be written as that, right? 2 can be written as that, right? And then we have 2k root 5, right? Let's see, this their base is 2 and their base is 2. 2k plus 1 root 5. Yeah, you add the exponent. Okay. So you see that?
Yes.
Okay, you see that now. So we multiply top and bottom by 2. What about here? What do we multiply top and bottom by? So that we have 2k plus 1 is equal to 5. What is that magic number? 2 to the minus 1? 2 to the minus 1 will not work. 2 to the minus 1, you give a good try.
2.
5. Let's see what happened. 2k minus 1 minus 1. You made it worse. Instead of getting k plus 1, you're getting k minus 2. But you are in the right direction. 2 to the 2? Good. Yeah, 2 to the 2. Good. 2 to the 2. That's it. So you multiply it by 4 and 4. You see that? Okay. Because you helped him see it and he saw it. Okay. All right, now instead of 4, you can write 2 over 2, 2 raised to 2, right? Okay. You write it that way, it helps you. Now you say that this guy is 2k plus 1 root 5. We already saw that, right?
Yes.
Okay. Now you're going to distribute that 2. So 2, 1 plus root 5, k. Minus 2, 1 minus 5, k plus 4, 1 plus root 5, k minus 1, minus 4, 1 minus root 5, k minus 1. Okay, we distributed 2, right? Because we multiply top and bottom by 4, we multiply top and bottom by 2. So we had to make sure that we distribute it.
Can I cancel it?
No, nothing cancels. That's bad. We have to somehow do something. How many? Okay, so we have to factor out. This guy look good with which one? This guy look good with which one? Right? This guy look good with this one, right? And this guy look good with this one. However, here is how many you have. Okay, if I give you like apple, okay, how many apple you have? So which one are you gonna take? You're gonna take this apple or this apple? If this is 10, if this is 2 apple, this is how many apple? 1. So this is just notation. It's a very simple thing. Okay. So if it is simple, then how can we do that? How can we make it look simple? We can do something. We can write 2. We're not gonna write the denominator anymore. Okay. So 2. We're gonna write 1 plus root 5. 1 apple. 1 plus root 5, k minus 1. You okay with that? 1 plus root 5, k is equal to what? 1 plus root 5, 1. 1 plus root 5, k minus 1. Is that okay? Because, why?
Oh, okay.
Because the same reason we explained before. Because the base is what? 1 plus root 5, k minus 1, plus 1. So you get what you have. Okay. A little bit painful. Okay. So this is this, no doubt. Minus. If this one we can do like that, we should be able to do this one like that. 2, 1 minus root 5, 1. And then 1 minus root 5. K minus 1. Plus 4, 1 plus 5. K minus 1 minus 4, 1 minus 5. K minus 1. Now, we're going to move the things around so that we can factor out. Okay, so 2, 1 plus root 5, similar to what? 1 plus root 5.
To the k plus 1? To the k minus 1?
Oh, okay. So 1 plus root 5, k minus 1 look like this one, right?
No.
Yeah, k minus 1. So then plus 4, 1 plus root 5, k minus 1. Right? Right? We have these two now and this one, right?
Yeah.
We're going to have now negative 2, 1 minus root 5, 1 minus root 5, k minus 1, minus 4. Minus 4 what? 1 minus root 5, k minus 1. All right. Now we finally have something to factor out. What are you going to factor out now? This guy and this guy, right?
But
What about 4? 4 not gonna bother us. We're gonna put 4 in good use. Because how can I factor out 4? Because I don't have 4 over here. Oh no, this is 1 and this is the other. This is the 1 plus 5. This is 1 minus 5. Remember, we keep that in mind. So our end has to be look like that. And it has to look like that. One has to be like that, one has to be minus that. So far we made some progress. Okay. All right, so 1 plus root 5 k minus 1.
2.
Then what do we have? 2 plus 2 root 5 plus what? Plus 4. We good? We good, right? We good. Minus. We're gonna have factor out something. 1 1 minus root 5 k minus 1 2 minus 2 times root 5 plus plus 4. K plus 4 what? Okay, that's it. Now we're gonna write 1 plus root 5 k minus 1 1 plus 2 root 5 plus 5 minus 1 minus 5 k minus 1 1 minus 2 root 5 plus 5. Is that okay? 2 plus 4 is what?
6.
1 plus 5 is what? 2 plus 4 is what?
6.
1 plus 5 is? We did it for a reason. 1 plus square root of 5 k minus 1 1 plus square root of 5 is square. Magic. This is equivalent to this one. Should we prove that or we believe that? Okay, let's see. 1 plus square root of 5 is what? 1 square plus 2, 1 root 5 plus root 5 is square. Then 1 plus 2 root 5 plus 5, right? So then if this one is this one, then this one is this one. So I can do that, right? Okay, minus 1 minus square root of 5 k minus 1. Then if this one is this one and this one is this one, then what is this one? There you go. 1 minus what? Root 5 what? There you go. Do we have same base?
Yeah.
Then 1 plus root 5 k minus 1 plus 1 minus root 5 k minus 1 plus 2 over what? I don't know, over what? Somewhere we done 2 k plus 1 root 5. Now we're gonna write the final line. 1 plus root 5 k what? K plus 1 minus 1 minus 1 minus root 5 k plus 1 divided by 2k plus 1 root 5. And that's what we claim that we're going to prove. Good. So we are able to prove that. I tried at home, I was unable to prove that. So I thought I was not going to be able to prove that.
So why are you doing it on the quiz?
I'm going to give you the proof, but I'm going to put one mistake. Yeah, but there is no way I'm going to ask you to prove that. I'm going to put 1 or 2 mistake inside, so you're going to find the mistake.
So you're gonna have the whole all the
Whole thing
laid
typed.
out.
Yes.
We're just gonna have to go through the math and find.
Yeah, find 1 or 2 mistake.
Okay.
Yeah. Okay, we have 2 more proofs, and then we're going to do the coding. Yeah, that one was little crazy. Is the most elegant proof in recursive function.
Where did he get the formula from?
Fibonacci himself.
He just like.
Well, nobody knows how they come out with this crazy formula.
There's actually a very interesting article that with the golden ratio, Beyonce is the second most pretty woman in the world.
Say it again, golden.
Using the golden ratio, I actually circulated the article with a couple of the colleagues, but using the golden ratio, Beyonce is the second most beautiful woman.
Oh, Beyonce, yeah, okay. We have to ask We have to ask we have to ask Jay-Z about that.
So that was pretty interesting.
I'm sure he's the lucky man then. Okay. Okay, so the next two proof is nothing compared to this. Okay, that's like baby proof. So easy.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.